Bismillahirrahmanirrahim. Assalamu alaikum. First, a brief introduction of myself. My name is Engineer Shahbaz Ghani. I have done my BS Mechanical Engineering from College of Electrical and Mechanical Engineering. Then I have done my Masters in Vehicle Engineering from Beijing Institute of Technology. And these are the emails with you can approach me. Now, a few words about the course, the Internal Combustion Engine. This is a basic course which is taught to the engineering students of final year of mechanical engineering. Now, the book which I recommend to you is the Engineering Fundamentals of Internal Combustion Engines by Mr. Willard. This is a good book, a very basic book for the learners. Now, chapter 1, Introduction. First, to give you the overall broader perspective, what is the internal combustion engine and how it is function, why it is there in the vehicle. So you need to understand this power flow or powertrain that is of conventional rear wheel driven vehicle. Your engine, the source of a power is developed by the engine. Then this power has to be transmitted to the wheels. How it is transmitted to the wheels? By the help of the flywheel and clutch. From that clutch, the power goes to the gearbox. That gearbox is known as the transmission. And from that transmission, the power goes to the or transmits to the propeller shaft. It is also known as the prop shaft. And then from the prop shaft, it goes to the differential box where it is distributed to your right and left wheels and your vehicle move. So in this internal combustion engine course, we will be only dealing with the engine power, engine, IC engine, internal combustion engine. Rest of this is we will cover in our another subject, that is automotive technology. So we will be focusing on engine now. Now, what is internal combustion engine? Internal combustion engine is a heat engine that converts chemical energy of a fuel into mechanical energy, usually made available on a rotating output shaft. So the internal combustion engine is basically a heat engine that converts the chemical energy of a fuel or air-fuel mixture into the mechanical energy that is available to you on a rotating output shaft. That rotating output shaft is your crankshaft. So the heat engine converts the chemical energy of a fuel or fuel mixture or a fuel into a mechanical energy, and that energy is available to you on a crankshaft in simple terms. Now, engine, a machine for converting any of various forms of energy into mechanical force and motions. Commonly referred to a device which converts chemical energy of a fuel into mechanical power, mainly by combustion. Combustion process is a very intricate process we will study in detail in later chapters. But just to give you a brief idea, there are two types of combustion. One is external combustion engine and other is internal combustion engine. Few examples of external combustion engine are steam engine, steam power plants. Internal combustion engines are car, generators, and gas turbines. Now, our focus, as I already explained to you, is in internal combustion engine. Internal combustion engine have following common types: reciprocating one, rotary one, and continuous one. In reciprocating, we generally have in our cars or motorbikes engines. Rotary, most common example for rotary type engine is of your Mazda RX-8. Continuous, we have a gas turbine engine and jet engines. All IC engines follow a similar heat cycle, but reciprocating engines are the best to understand the steps, how the phenomena, what is going on there. Okay. So we will mainly focusing on the reciprocating engines. And in reciprocating engines, the common two variants are with respect to the strokes. And one is two-stroke and one is four-stroke. In two-stroke, every downward stroke delivers power. Advantage of two-stroke is more power per weight and displacement. Displacement is basically the volume of a cylinder. So we have a more power per weight and displacement as shown here. And in four-stroke, every other downward stroke delivers power. Advantage of four-stroke, better efficiency, control, and overall emission. These are the four strokes. We will study in detail about these strokes later on. Now, just to give you the brief introduction of the engine components, a small video clip, I will be explaining a few major parts here. Engine is basically divided into three major parts: the engine head, the engine block, and the crankcase. So let's see this video. This portion is known as the engine block, which contains the cylinders inside here. Okay, these are the four cylinders here, and this is the crankshaft. And with crankshaft, we have connecting rods, and then we attach the connecting rod with pistons. Okay, there are four cylinders, so four pistons. We are attaching the piston group with the crankshaft, the cylinder block. Then we have a flywheel on this end, and this portion is known as the engine head. First was the engine's block, the cylinders, and then this is the engine head, in which we have the intake valves and the outlet valves. And these inlet and outlet valves are controlled or moved by these camshafts. These are the overhead camshafts which hold the opening and closing of the inlet and the valve. So we have two camshafts here for inlet and the exhaust valves. Now these are the things for the timing of these camshafts with respect to the crankshaft, the core of this sustain. Then we have a cover of the engine head, along with the gasket and the filling trap from where we fill the oil. Then the lower portion is also known as the crankcase or the pump, third most important part of the engine block. It is attached at the bottom of the engine block. It sources all the oil of the engine. Then other accessories, this is the start starter, right? The flywheel, pattern, engine, the other accessories. Now we have here the intake manifold. Okay. This is the carburetor or the engine. This is the oil dipsticks, and with the help of the dipsticks, we measure the oil levels, fuel injectors, and the spark plug station. Okay. Then we have a water pump body attached with the engine block, fully arranged to drive the water pump. Then the gear mechanism, then we have a alternative assembly, then we have POS assembly, then the generator assembly. Up, all the attached with the pipes, and then we have a exhaust financial way, from where the exhaust goes to the environment. So this was the brief video clip for the engine components. I hope you understood this. Now, engine classification. How we classify the engine. A brief chart. First, main thing is all internal combustion engine or external combustion engines are heat engine because they are producing heat and with the help of chemical reaction, and that heat energy is converted into mechanical energy. Okay. Now, heat engines, we have a internal combustion engine, external combustion engine, then further categorized as rotary and reciprocating in both sides. In IC engine, the rotary, we have further open cycle gas turbine, Wankel engine. In reciprocating, we have a gasoline engine or SI engine. We have a diesel engine or a CI engine. In external combustion engine, we have a reciprocating and rotary. In reciprocating, we have a steam engine and Stirling engine. In rotary, we have a steam turbine and closed cycle gas turbine engine. IC engine, we can classify with respect to the strokes, 4-stroke engine, 2-stroke engines, and these with the help of strokes. Then we have an SI engine in which we have a petrol engine or gas engine. We may have a carbureted type, injection type, battery ignition, magneto ignition. In CI engines, we have a dual fuel, multi-fuel engine, dual chamber engine, and then we can further classify with respect to the pre-chamber or swivel chamber. Then we can further classify the IC engine with respect to the cooling method, or maybe what that may be water cooled or air cooled. Then we can have with respect to the different number of cylinders, we have reciprocating multi-cylinders in which we have a V configuration. 4 means 2 on right side, on 2 on left side, and 6, 3 on either sides. 8, 4 on left and 4 on right. And 12 means 6, one bank contains 6 cylinders, other bank contains 6 cylinders. Incline type, in which we have different types of cylinder configuration. In opposed cylinder, we may have 2, 4, or 6. Then in rotary Wankel, we have a single rotor or a twin rotor. That depends. Now, to ease these charts, let's see the engine classification with respect to the types of ignition. First, there are 2 types of ignitions. One is spark ignition. Those are also known as SI engine or spark ignition engine, in which there is a spark with the help of a spark plug. Second is the compression ignition engine, also known as CI engine, in which we have compressed the air to that limit and then we inject the fuel in that high pressure, high temperature compressed air, and due to that high temperature, high pressure compressed air, fuel is injected and then the compression took place. So with the help type of ignition, we have SI engine and CI engine. Now, with respect to the engine cycles, we have a 4-stroke cycle. Let me explain you the strokes now. In 4 strokes, the first stroke is the intake stroke. Then second stroke is the compression stroke. Third stroke is your power stroke or expansion stroke. And the fourth stroke is the exhaust stroke. And all these 4 strokes, they take 720 degrees of crankshaft rotation. 2 revolutions, complete revolutions of a crankshaft makes the complete 4-stroke cycle. As far as 2-stroke cycle are concerned, we have only 360 degrees of revolution of rotation, means 1 revolution of a crankshaft completes all the 4 processes in 2-stroke. In first stroke, which is moving from BDC to TDC, the bottom dead center to top dead center, we have intake stroke and compression stroke. And then we have a combustion there. Then the piston moves from TDC to BDC. We have a power stroke and exhaust stroke. So in 360 degree, we are achieving all the 4 cycles in 2-stroke, and in 720 degree, we are achieving these 4 strokes. Okay. Now, with respect to the valves location, the valves are inlet valves and the exhaust valve. If the valves are in head, we call it overhead valves, also called as I-head engines. If the valves are in block, we call it as flathead, also called as L-head engines. Now, with respect to the basic design criteria, these are the reciprocating type and the rotary type. Now we can further classify engine with respect to the position and number of cylinders of reciprocating engine, single cylinder, inline, V engine, opposed cylinder engine, W engine, opposed piston engine, and radial engine. Let's see the figure. This is inline. Now, if we have one cylinder, two cylinder, three cylinder, or four cylinder or six cylinder, they are all inline. So we call them inline. If we have this type of a configuration, U cylinder. If we have a V-type configuration, we call it a V-type. We have X type, then radial type, then H type. In opposed cylinder, we have a same crankshaft, but two different cylinder and two different pistons. Okay, but the crankshaft is the same. As opposite of this, we have opposed piston, in which we have single cylinder, but two pistons moving in opposite direction. And we have a two crankshaft here. Here we have a single crankshaft. Here we have two crankshaft with two pistons attached on them. Now we have a delta type in which we have a three cylinders and six pistons moving opposite. Okay. So with the help of number of cylinders, we can also classify the engine. Now, with respect to the air intake process, we can further classify the engines. First one is the naturally aspirated engine. Naturally aspirated engine in which if the piston in intake stroke moves from TDC to BDC, top dead center to bottom dead center, there is a suction and air from the atmosphere naturally rush in to fill that vacuum. That is your naturally aspirated engine. Now, if we have a supercharged engine, means we have placed a supercharger on the intake manifold. With the help of that supercharger, a compressed air is forced into the combustion chamber. That is your supercharged engine. Now, again, another type is turbocharged engine or turbocharged or turbine. On the exhaust side, near on the exhaust manifold, we placed a turbine or turbocharger. The function of the turbine or turbocharger is to extract the exhaust gases during the exhaust stroke, and this extraction is so high that it produced a vacuum there. So to fulfill that vacuum, air has to be rushed in, and we placed a fan there to break that vacuum. So this is your turbocharged engine. Crankcase compressed engine in which the air and fuel mixture comes in two-stroke engine. Air fuel mixture is come to the crankcase, there it is compressed and then fed to the combustion chamber. Now, with respect to the fuel, you can also classify the SI engines. Previously, we were having the carburetor or carbureted type in which air from the air intake manifold, air filter is coming to the carburetor and fuel is coming from the fuel side. In carburetor, the air fuel mixture is created and that air fuel mixture then goes to the intake manifold and then to the cell combustion chamber. In multi-point fuel port injection, we will study all these in chapter 5. Multi-point fuel port injection is you inject fuel at the intake manifold at before the cylinder at different locations. Okay, so this is multi-point. Then throttle body fuel injection in which with the help of throttle body we inject the fuel. Now, with the respect to the fuel, you can also classify an engine. If you are using a gasoline fuel, you call it as a gasoline engine. You are using diesel engine. Then you can have a gas or natural gas or methane. Then you have LPG, liquefied petroleum gas engine. Then you can have alcohol, maybe ethyl alcohol or methyl alcohol. Then fuel engine. Dual fuel, maybe you are using petrol and diesel in certain ratio, or kerosene oil and diesel in certain ratio in some engines. Gasol, another form of an alcohol engine, gas and alcohol. Then with respect to the cooling, you can also classify the engine. First is the air-cooled engine. In air-cooled engine, basically you have the fins on the body of the cylinder block or head, which cools down with the help of air, the engine. Then most commonly used is the liquid cool or water cooled engine. Now presently with the advancement of the technology, we are using coolants as a water cooled engine or liquid cooled engine. Now with the application, you can also classify the engine. The automobiles, we have a small engine. If we have a huge truck or big bus, we can classify that engine as a heavy engine. We have a locomotive engine. Stationary means we have a generator set or other some equipment like this. We that is known as stationary engines, marine engines, aircraft engines, small portable chainsaw model aeroplanes. We can classify with different factors. Now, terminologies and abbreviations used in the internal combustion engines. First is the spark ignition, SI, an engine in which a combustion process in each cycle is started by use of a spark plug. In every engine, combustion process is the process in which you get the ignition and the fuel is burned, and that burning of the fuel is known as the combustion process, and that combustion process start with the help of a spark plug. If a spark plug is there, then it is a spark ignition or SI engine. And other form, the compression ignition, CI engine, an engine in which the combustion process starts when the air-fuel mixture self-ignites due to high temperature in the combustion chamber caused by high compression. So remember this thing, in compression ignition engine, we don't have a spark plug, but we get the ignition of air-fuel mixture due to self-ignition. And that self-ignition is due to high temperature and high pressure in the combustion chamber. Okay. Now, top dead center, PDC, piston of position of a piston when it stops at the furthest point away from the crankshaft. Let's see the figure. Now, this is your crankshaft, and this is your connecting rod, and this is your piston. Now, piston at this maximum upward position, that is known as your top dead center. When this crankshaft will rotate and this portion crank pin will come in this point, the piston will be at this location, that is your bottom dead center. Okay. Now, position of the piston when it stops at the furthest point away from the crankshaft, that is the top dead center. Now, remember these two terms, ATDC and BTDC, very important. This small alphabet A is, when it is written with ATDC, it has a specific meaning. When BTDC, also has a specific meaning. The position is top dead center. A means after top dead center. B means before top dead center. Now let's see if the piston is moving in this direction, okay, the piston reaches from BDC to this at this location. So we will say BTDC, before top dead center. Now piston reaches top dead center at this location and going down. And we then at this location or at this location, we will say after TDC. Okay. So remember this ATDC and BTDC. Bottom dead center, position of the piston when it stops at the point closest to the crankshaft. This is furthest point and this is closest to the crankshaft, the bottommost. Okay. Then we have direct injection, DI. This is with respect to the fuel injection system. Fuel injection into the main combustion chamber of an engine. If we are injecting fuel directly into the combustion chamber, means the cylinder block of an engine, that is your direct injection. Okay. Now, indirect injection, if the fuel is injected into the secondary chamber of an engine with a divided combustion chamber, means you are not injecting the fuel directly into the cylinder or the combustion chamber. You are injecting the fuel. Let's suppose you are injecting the fuel at the intake manifold or in the carburetor. That is your indirect injection system. Now, bore. Diameter of the cylinder or diameter of the piston face. Let's see. This is the diameter of the piston face, or if we have a cylinder here, then we have a diameter of the cylinder. This is your bore. Diameter of the cylinder or diameter of the piston face is called as bore. Stroke. Movement distance of a piston from one extreme position to the other extreme. From TDC to BDC or BDC to TDC. Let's see. If the piston is at TDC and it goes to the BDC, then it is a one stroke. Or if it goes from BDC to TDC, then it is also a one stroke, and stroke that is equal to L. Okay. So moment of a piston from TDC to BDC or BDC to TDC is known as a stroke. The clearance volume. Minimum volume in the combustion chamber when the piston is at TDC. When your piston is at top dead center, the maximum point the piston can achieve in the cylinder is your top dead center. But there is a space above that piston face. Here on the top, we have a piston head. This portion is your piston head. Okay. And then this portion is your engine block. And this portion, which is above the piston head, that clearance, that space is known as the clearance volume. Minimum volume in the combustion chamber when the piston is at TDC. Displacement or displacement volume. Volume displaced by the piston as it travels through one stroke. Now, what is displacement or displacement volume? Volume displaced by the piston as it travels through one stroke. Now, if the piston is at your BDC, now piston moves from BDC to TDC, the volume displaced from BDC to TDC, that volume is your displacement. Or some literature calls it a swept volume. So I say again, volume displaced by the piston as it travels through one stroke. Some literatures call this swept volume. Now, other term is smart engine. Engine with computer controls that regulates operating characteristics such as air-fuel ratios, ignition timings, valve timings, exhaust control, intake tuning, extra computer inputs from the electronics, mechanical, thermal, and chemical sensor located throughout the engine. All the modern engines which are coming now are smart engines. We have a ECU, engine control unit. All the controls are done by the computerized system there. So all the latest engines are all falls in this category of smart engines. Engine management system, computer and electronics used to control the smart engines. Wide open throttle, very important terminology because we will using this term in our chapters 2 and chapter 3. Wide open throttle. Engine operated with throttle valve fully open when maximum power and or speed is desired. When we are using conventional engine or old engine in which we have a carburetor system, in carburetor system we have a throttle valve. Throttle valve is linked with your accelerator. When you press the accelerator fully, the throttle valve or that butterfly valve fully opens, and that position is known as wide open throttle. So engine operated with throttle valve fully open when maximum power and or speed is desired. So when you press the accelerator pedal, when you press the accelerator pedal, it means you require maximum power or speed. So it opens the valves fully so that more air fuel mixtures come in and you have a maximum speed or power. That is your wide open throttle condition. Now, few words regarding the engine components. There, as you have seen in the video clip, three parts. Engine you can divide into three major parts: head, block, body, and crankcase, also known as sum. Head, the upper part, the part of the engine containing the camshafts, valves, and manifolds, inlet, exhaust, that is known as your engine head. Then the second part is your block, body of engine containing the cylinders, sleeves made of cast iron or aluminum and channels for coolant and lubrication. The central portion of your engine, the body which contains your cylinder in which we have sleeves in which your pistons move, made of cast iron or aluminum, and channels. There are few lubrication channels and coolant channels where the lubrication oil flows and the water or the coolant flows. Then the lower portion, the crankcase or the sum. The lower part of the engine containing the crankshaft and oil pan and stainers. Then we have a camshaft, rotating shaft used to push open valves at the proper time in the engine cycle, either directly or through mechanical or through hydraulic linkages. Camshaft drives the inlet valves and the exhaust valve. They are specifically designed, they have a specific shape which have a cam lobe and follower arrangement which opens the valves at a required time in a stroke. They either can be directly or through mechanical or hydraulic linkages. Carburetor. Venturi flow device which meters the proper amount of fuel into the air flow by means of pressure differential. Carburetor is an assembly in which we have a venturi flow device which meters the proper amount of a fuel into the airflow by means of a pressure differential. All your old vehicle and conventional vehicle, we have this carburetor arrangement, but now with the help of advancement in technology, this carburetor arrangement has been changed or replaced with the help of fuel injectors. Now, combustion chamber. The end of the cylinder between the head and the piston face where the combustion occurs. When your piston reaches TDC, the only volume space which we have that is the clearance volume, and that clearance volume where the combustion ignition starts, and that ignition starts and then leads to the combustion, and that area or the space is known as the combustion chamber. The end of the cylinder between the head and the piston face where combustions occur. Connecting rod. Rod connecting the piston with the rotating crankshaft. Remember this thing. What is the linkage between the piston and the crankshaft? That is your connecting rod. Connecting rods which connects the piston and the rotating crankshaft. Cylinders. The circular cylinders in the engine block in which the piston reciprocates back and forth. These cylinders are also known as sleeves. Crankcase, part of the engine block surrounding the rotating crankshaft. Crankshaft, rotating shaft through which the engine work output is supplied to the external system. Mainly that external system first is the flywheel. On the crankshaft, we place the connecting rod, and connecting rod is linked with the piston. Catalytic converter. In modern vehicles and the latest vehicles or the today's vehicles, we have this assembly or device, catalytic converter. Catalytic converter is the chamber mounted in the exhaust flow containing catalytic material that promotes reduction of emission by chemical reaction. Remember this thing, when there is a combustion, it is not ideal. It is not 100%. So there is emission problem. We have NOx, we have carbon monoxides, we have excessive carbon dioxide. So this catalytic converter reduces those emissions by chemical reactions and give a clean exhaust. Okay. Now, figure, as you see, this upper portion is your cylinder head or cylinder head cover. This is your cylinder head in which you have a valve system and a cam system, then you have a gasket, then you have this engine block in which these are the cylinders in which your pistons move, and then you have a crankcase in which, or the sump in which, and this is your exhaust manifold and this is your intake manifold. Now the fuel pump. Fuel pump, which is the source of providing fuel to the combustion chamber, is either electrically or mechanically driven pump to supply fuel from the fuel tank reservoir to the engine. Intake manifold. A piping system which carries air cleaned or compressed to the engine cylinder. If it is an old engine, then it contains air fuel mixture. If it is a new or latest engine, then there will be pipings which only the air is there in the intake manifold. Exhaust manifold. Piping system which carries exhaust gases away from the engine cylinder. Then we have a flywheel, a rotating mass with a large moment of inertia connected to the crankshaft of the engine. A heavy mass or heavy large mass with large moment of inertia connected to the crankshaft of the engine. Fuel injectors. A pressurized fuel nozzles that sprays fuel into the incoming air on SI engines or into the cylinder or CI engines. So these, instead of the carburetor, you have a fuel injectors and the pressurized nozzle that sprays fuel into the incoming air in the SI engines or into the cylinder on CI engine. Glow plug. Remember this thing. This glow plug is different than spark plug. Glow plug basically a small electrical resistance heater mounted inside the combustion chamber of many CI engine. Before starting an CI engine, we normally use a terminology. Let's give the heater. Let's start the heater. Basically, that heater is you are switching on your glow plug. Glow plug is basically a small electrical resistance heater mounted inside the combustion chamber of many CI engine, which heat up the surrounding air to, to increase their temperature and pressure, basically increase their temperature for easy combustion. So glow plugs are used in CI engines, not in SI engine. Remember this thing. Now the piston. The cylindrical shaped mass that reciprocate back and forth in the cylinder, transmitting the pressure forces in the combustion chamber to the rotating mechanism. The piston is attached with your connecting rod, and then connecting rod is attached to your rotating crankshaft. Basically, it's a cylindrical shaped mass that reciprocate back and forth in the cylinders, transmitting the pressure forces in the combustion chamber to the rotating crankshaft. Piston ring. Metal rings that fit into the circumferential grooves around the piston and form a sliding surface against the walls. Okay. These are basically of soft materials as compared to the pistons. These are the rings that fit into the circumferential grooves around the piston and forms a sliding surface against the cylinder wall. There are two types of rings, compression rings and oil rings, or call it scraper rings. First, on the top, we place the compression rings. Basically, that holds the compression in the combustion chamber, and the oil rings which holds the oil in the lower portion, or scraper which scraps the oil from the walls of the cylinders. Head gasket. Gasket which serve as a sealant between the engine block and the head where they are bolted together. Remember one thing. Whenever you have to bolt or fasten two metal portions, you definitely have to use some gasket material, okay? The material which covers the tolerances, okay? Because when you machine any metal surface, there are some allowances, there are some tolerances. So to cover those allowances or tolerances or that gap, to fill the gap, you need to have some gaskets. So when you have a head gasket, the head and the block is fastened together, you place a sealant between that gasket, okay? Main bearing. The bearing connected to the engine block in which the crankshaft rotates. Crankshaft is connected with your connecting rods, that is your shell bearings, but it has to be connected to the block. So when it is connected to the block, the bearings which connects them, those are called main bearings. Then we have a radiator. In liquid cooled engines, we have a radiator, that liquid to air heat exchanger of honeycomb construction used to remove heat from the engine coolant after the engine has been cooled. Spark plug. The electrical device used to initiate combustion in an SI engine by creating a high voltage discharge across an electrode gap. Spark plug is used in an SI engine. Basically, at the end of the intake stroke, at the end of your compression stroke, the spark plugs give the ignitions to that air fuel mixture with the help of that spark, the ignition, then ignition leads to the combustion. And remember, the spark plugs are always in SI engines, not in CI engines. So, and let me explain you. This is your intake manifold. Okay, this portion, the air is coming. This is your throttle valve or butterfly valve, and fuel is coming here. Here, this is your intake valve. Okay, then this is your cylinder. Here we have a spark plug. Then this is your exhaust valve. Then this is your exhaust manifold. You have this cylinder block here. This is the water channels. Okay. Here you have this piston. Around the piston, here you have compression rings. Here you have oil rings. And this is known as gudgeon pin or piston pin. Okay. Then we have this connecting rod. And connecting rod, we have a crank pin here. And this is your crankshaft. And this lower portion is called as crankcase or sump. And this portion from here to here, it is known as cylinder block. Here we have camshaft, cam. This is spring arrangement, the valve intake mixture is coming in. Here you have the combustion chamber. These lines, the grooves, basically, these are here you place your compression rings, and here you place your oil rings. The cylinder block, connecting rod, crankshaft, crankcase. Here, these are the channels in which you have a cooling medium liquid. Then this portion is your cylinder block, exhaust valve, spring arrangement, camshaft, and this is your spark plug. Now, basic cycles. There are in 4-stroke. First is the intake stroke, in which piston from this TDC position goes to the BDC position, and intake valve is open. That is your intake stroke. When piston is at BDC, coming from TDC to BDC, your intake stroke finishes. Piston starts moving from BDC to TDC. You have a compression stroke. Your intake valve closes. Okay. Piston reaches TDC. Your compression strokes finish, and when your piston reaches TDC, you have a spark here and ignition start, and which leads to combustion. And we have a combustion here. Both valves are closed. Piston from TDC moving towards BDC, and this is your power stroke or expansion stroke. When piston reaches to the BDC, your power stroke finishes. When piston starts its movement from this BDC to TDC, your exhaust valves open and you have a exhaust stroke. So these are the basic simple 4 strokes: intake stroke, compression stroke, power stroke, and exhaust stroke. Basically, it's the piston movements from TDC to BDC and BDC to TDC, and the function of a spark plug, the combustion. Now, brief. Oh, says the ignition, combustion, power strokes, then exhaust, then intake strokes, then again the spark plug combustion, piston goes down, then coming up with this exhaust valves and intake open. So this is how your 4 strokes works. Okay. Now, just to encourage you, and let's see how simple it is. Disassembling and assembling of an engine. We are now disassembling the small sub-assemblies of an engine. head, other assembly, intake, different assemblies, flywheel, camshaft, valves, head. Now we are removing the springs and valves, draining the oil, removing the sump, removing the other accessories, then removing the crankshaft and pistons. Now assembling all these after washing and cleaning. Okay, this is the head assembly, the other crankcase, head, side plates, walls, intake walls, exhaust walls. All are again assembled. Transmission is also fitted in the vehicle, and it's ready to use. How simple it is. Okay. Few bolts and nuts are left behind. Now, further explanation, as I already explained, intake stroke piston is moving from this TDC to BDC. Okay. Inlet valve is open and we have a intake here. Piston is at BDC. Intake valve is closed and piston is moving towards TDC, and we are compressing the air fuel mixture here. And when piston reaches TDC, you have a spark here. Ignition starts and combustion starts. Now piston moves from TDC to BDC, your power valves are closed. When it reaches the BDC, power stroke finishes and it moves again from BDC to TDC. Exhaust valve is open and you get the exhaust. Now, in first stroke, the intake stroke or the induction, the piston travels from TDC to BDC with intake valves open and exhaust valve closed. This creates an increase in volume in the combustion chamber, which in turn creates a vacuum. The resulting pressure differential through the intake system from atmospheric pressure on the outside to the vacuum on the inside causes the air to be pushed into the cylinder. When piston is moving from TDC to BDC, it's creating a large volume. Large volume is creating a vacuum. To fill that vacuum, we have a pressure differential and intake valve is open, so air from the atmosphere will rush into that vacuum to fill that vacuum and that volume. As the air passes through the intake system, the fuel is added to it in the desired amount by means of fuel injector or a carburetor. So, second stroke, when the piston reaches BDC, the intake valve closes and the piston travels back to the 180 TDC with the all valve closed. So from TDC to BDC, it has covered 180 degree. Remember this thing. So one stroke is equivalent to 180 degree. Now in second stroke, the compression stroke, piston starts moving from BDC to TDC and intake valves close. This compresses the air fuel mixture, raising both the pressure and temperature in the cylinder. So both valves are closed. Piston is moving from BDC to TDC. It is compressing the air fuel mixture. By compressing the air fuel mixture, we are increasing the pressure and the temperature. The finite temperature Finite time required to close the intake valves means that actual compression does not start until sometimes BDC. Near the end of the compression stroke, the spark plug is fired and combustion is initiated, as I explained earlier. Now, spark plug have given the spark and the combustion started. Combustion of the air-fuel mixtures occur in a very short but finite length of a time with the piston near TDC, nearly constant volume combustion. Remember this thing. It starts near the end of the compression stroke slightly before TDC and lasts into the power stroke slightly after TDC. So when the piston is reaching to TDC, your ignition start and combustion starts. Piston reaches TDC, combustion is still going on. Piston starts its movement back towards BDC. After a few degrees, your combustion finishes. The combustion changes the composition of the gas mixture to the exhaust products and increase the temperature in the cylinder to a very high peak values. When you have a combustion, you have a burning there. With burning, the temperature and pressure rises and it produces exhaust products. Okay. This in turn raises the pressure in the cylinder to a very high peak value. So both your temperature and pressure increases and that pressure is exerted on the piston top. Now piston is going downward towards BDC and this is your power stroke starting. Okay. Third stroke, the expansion stroke or power stroke. With all valves closed, the high pressure created by the combustion process pushes the piston away from the TDC. This is the stroke which produces the work output of the engine cycle. As the piston travels from TDC to BDC, cylinder volume is increased, causing pressure and temperature to drop. So piston is moving from TDC to BDC. The volume is increasing. When volume is increasing, it getting more area. When getting more area, your pressure is dropping, your temperature is dropping inside the cylinder. Now, exhaust blowdown, another important phenomena. Late in the power stroke, the exhaust valve is open and exhaust blowdown occurs and pressure differential is created through the exhaust system which is open to the atmospheric pressure. Let me explain. This pressure differential causes much of the hot exhaust gases to push out to the cylinder and through the exhaust system when the piston is near BDC. When in power stroke, your piston from TDC is coming towards BDC. But before reaching BDC, your exhaust valves open. When exhaust valves open, the hot air gases, the exhaust gases, hot gases, they try to escape and they escape from the exhaust valve. Okay. This exhaust gases carry away a high amount of enthalpy, which lowers the cycle's thermal efficiency. Because of the hot gases emissions, it took the high amount of enthalpy with them, which lowers the cycle's thermal efficiency. Opening the exhaust valve before BDC reduced the work obtained during the power stroke. So the power stroke basically is the work done but the exhaust valve is opening before BDC. So the work done obtained during this power stroke is reduced but is required because of the finite time needed for exhaust blowdown. And this exhaust blowdown is very, very important because when piston in exhaust stroke, if your exhaust valve is not open and piston reached BDC, it has to come back. Hot gases are there, high pressure is there, so it will require more force. But before the BDC, if we open the exhaust valve, the hot gases will leave the chamber and the pressure exerting on the piston top will be less. So there will be no difficulty in the exhaust stroke to moving from BDC to TDC. So this exhaust blowdown is very, very essential in the four-stroke system. Now the exhaust stroke, the four-stroke. By the time the piston reaches BDC, exhaust blowdown is complete, but the cylinder is still full of exhaust gases at approximately atmospheric pressure. Cylinder is filled with exhaust gases and pressure is still very high, but it will approximately be atmospheric pressure, but still high. With the exhaust valve remain opening, the piston now travels from BDC to TDC in the exhaust stroke. This pushes most of the remaining exhaust gases out of the cylinder into the exhaust system at about atmospheric pressure, leaving only that trapped in the clearance volume when the piston reaches TDC. So most of the exhaust gases will leave the combustion chamber or the cylinder. Some of the exhaust gases will be trapped in the clearance volume, which is there, and they will remain there. Now, simple illustration. A four-stroke engine has the following: inlet valves open. This one in C in one. Inlet valves open. We valve second compression, power, and 4 is the exhaust stroke. Inlet valves open, fresh air fuel mixture drawn in, piston goes down. Valve closes, compression of the mixture, piston goes up. Ignition, either spark or compression, piston in the top position. Power stroke, valve closed, piston goes down. Burned fuel, exhaust valves open, piston goes up. Intake, compression, power, and exhaust. Now, four-stroke CI engine. This previously it was for SI engine. Now, what happens in CI engine when we have a four-stroke CI engine? First stroke, intake stroke, the same as the intake stroke in the SI engine, with one major difference: no fuel is added to the incoming air. In SI engine, we are receiving air-fuel mixture in the intake stroke, but in CI engine, there is no fuel added in the incoming air. Second stroke, compression stroke. The same as in an SI engine, except that only air is compressed and compression is too high pressure and temperature. Late in the compression stroke, fuel is injected directly into the combustion chamber, where it mixes with the very hot air because of high pressure and high temperature. This causes the fuel to evaporate and self-ignite, causing the combustion to start. Now, combustion is fully developed by TDC and continue at about constant pressure until fuel injection is completed and the piston has started towards BDC. Before TDC, the combustion started. At TDC, combustion fully developed. After TDC, the combustion completed. Okay. Now, third stroke, the power stroke. The power stroke continue as the combustion ends and the piston travels towards BDC. Exhaust blowdown, same as with an SI engine, same phenomenon. Fourth stroke, same as with the SI engine. Your exhaust valves open and exhaust gases goes out. Only difference is you have only air incoming, no fuel added in the intake stroke, and fuel is added when your piston is reaching at TDC, then you inject a fuel there. Intake valve open, piston is moving from TDC to BDC, suction is there. Intake valve close, piston moving from BDC to TDC. When it reaches TDC, before TDC, you get the injection of the fuel. Ignition starts due to high temperature, high pressure of the air. Piston from TDC to BDC moves down. You have a power stroke or expansion stroke, both valves closed. And when piston moving from BDC to TDC, exhaust valves open and you have a exhaust stroke. Two-stroke engine. Two-stroke engine has following mechanism. A mixture of air, fuel, and lubricating oil is present in the engine block indicated by light blue. This is your intake. From here we are getting air fuel mixture. Okay. Air fuel mixture is coming here. This is your crankcase. Crankcase is filled with oil. So air fuel is his crankcase compression. Air fuel mixture is mixing in. When the piston is at the bottom position, that fresh mixture moves in and help extract all burnt fuel. Now, piston is at the bottom, the air fuel mixture is coming in. As the piston starts moving upward, first the inlet port, this is your inlet port, and then the exhaust port sealed. This is your exhaust port. Piston is moving from BDC to TDC. Your inlet port is closing, then your exhaust port is closing, and you have a compression here. And after it reaches the top position, ignition occurs due to a spark or a compression. The piston moves downward due to the force exerted by the burnt fuel-air mixture, and the exhaust ports gets open first. When the piston is moving from TDC to BDC, first the exhaust port is uncovered. So exhaust gases will flow out and the exhaust ports gets opened, first letting the burnt fuel out, and then inlet port opens to supply the piston with new charge and push the burnt fuel. First see the exhaust port open, the exhaust gases goes in and the input, this piston uncovers the inlet ports. The fresh air fuel mixture comes in and it also forces the exhaust gases outward. Okay. Same, but here the piston top is different. Okay. This to give swirl action. Now, two-stroke SI engine combustion with the piston at TDC. Combustion occurs very quickly, raising the temperature and pressure to peak values almost at constant volume. First stroke, expansion stroke or power stroke. Very high pressure created by the combustion process forces the piston down in the power stroke. The expanding volume of the combustion chamber causes the pressure and the temperature to decrease as the piston travels towards BDC. Exhaust blowdown. At about 75 degrees before BDC, the exhaust ports or valves open or uncovered and blowdowns occurs. The exhaust port or valves may be a puppet valve in the cylinder head, or it may be a slot in the slide of the cylinder which is uncovered as the piston approaches BDC. After blowdown, the cylinder remains filled with the exhaust gases at lower pressure. Intake and scavenging. When blowdown is nearly completed at about 50 degrees before BDC, the intake slot on the side of the cylinder is uncovered and the intake air fuel mixture enter under pressure. Fuel is added to the air with either a carburetor or fuel injector. This incoming mixture pushes much of the remaining exhaust gases out of the exhaust port oblique valves and fills the cylinder with the combustible air fuel mixture, a process called scavenging. So the removal of exhaust gases with the help of air fuel mixture is called scavenging. The piston passes BDC and quickly covers the intake port, and then the exhaust port or the exhaust valve closes. In two-stroke SI engine cycle, the second stroke compression stroke, With all valves or port closed, the piston travels towards TDC and compresses the air-fuel mixture to high pressure and temperature. Both valves, intake and outlet, or exhaust valves or ports are closed. Near the end of the compression stroke, the spark plug is fired. By the time the piston gets to the TDC, combustion occurs and next engine cycles begins. So spring-loaded inlet valve, the air-fuel mixture is coming in the crankcase, then it is going to the from transfer port to the here, which is a deflector. It deflects in this there. Then you have a spark plug and the exhaust port. So this how the cycles took place: exhaust blow down and this quenching process. So this was all regarding the first chapter. I hope you should have understood something. If you have any problem, any query, please do consult me. And thank you for listening and watching. Thank you. Bye.